Hello everyone, myself Juli Yadav, Assistant Professor from Ajay Kumar Garg Engineering College, Ghaziabad. So today's topic is optimization of DFA based pattern matchers. So basically this topic we are studying in compiler design, and generally we use this optimization of DFA based pattern matchers to recognize the tokens. So as we know that there are 6 phases in the compiler design. So the first phase is the lexical analyzer, second phase is the syntax analyzer, third is the syntax analyzer, semantic analyzer, and fourth phase is the intermediate code generator, fifth phase is the code optimization, and the last phase is the code generator. So we use this topic in the first phase of the compiler, that is the lexical analysis phase. So introduction about this topic is, in this section we represent 3 algorithms that has been used to implement and optimize pattern matchers construct from regular expression. So it has 3 algorithms. The first algorithm is useful in a Lex compiler because it constructs a DFA directly from regular expression. Means through this topic, I'm going to tell you that how you can construct a DFA without constructing the intermediate NFA from the regular expression. So resulting DFA also may have fewer states than the NFA constructed from by the NFA. So the second algorithm minimizes the number of states of any DFA by combining states that have the same future behavior. The algorithm itself is quite efficient, running in time O of n log n, where n is the number of states of the DFA. The third algorithm produces more compact representation of transition table than the standard 2-dimensional table. So for this to find or to construct a DFA, that is the minimized DFA from any regular expression, we have to follow some sorts of steps. Like the first step is we have to construct the syntax tree from the regular expression that is given. Then we have the second step is to number the leaf nodes. Then the third step is to find the nullable. Then fourth step is to compute the firstpos, lastpos, and followpos of the regular expression, or we can say the syntax tree. So how we compute from the syntax tree? The function is to construct a DFA directly from a regular expression. We construct its syntax tree and then compute 4 functions. The first function is nullable, the second function is firstpos, third is lastpos, and followpos, defined as follows. Each definition refers to the syntax tree for a particular augmented regular expression R. Suppose we have given some sort of expression like A, B, C. So this symbol represents the end of the regular expression. While you are constructing or while you are given a regular expression like this, then you have to place this hash symbol at the end of the string or the regular expression to represent that this is the end of the regular expression. So the nullable function is true for a syntax tree node n if and only if the sub expression represented by n has E in its language, that is, the sub expression can be made null or the empty string, even though there may be other strings it can represent as well. So the first step, after completing the first step, we can compute the nullable of any node. Then we have to compute the firstpos of each node, whether the node is intermediate node or the leaf node. We have to compute the firstpos for every node. So the firstpos is the set of positions in the subtree rooted at n that correspond to the first symbol of at least one string in the language of the sub expression rooted at n. Right? By using this firstpos, we can calculate the first position of any node. Now, the lastpos is used to calculate the last position. So what the lastpos function is, when we want to find the lastpos of any node, it is the set of position in the subtree rooted at n that corresponding to the last symbol of at least one string in the language of the sub-expression rooted at n. So lastpos is what? It is the set of position in the subtree rooted at n. Now next pos is the followpos. Followpos is used to calculate, or it is used to compute the which symbol follows which symbol. So it is used for that. So what the followpos function is, when we want to find the followpos of any node P for a position P is the set of position Q in the entire syntax tree, such that there is some string. This represents the string in any language L of regular expression. And here you can see the hash represent what? The end of the regular expression, such that for some I, it is the, this symbol is used for the, I is used to represent the nodes. So there is a way to explain the membership of X in LR. This represents the end of the regular expression by matching the to the position P of the syntax tree and AI plus I to the position G for the next node. So this is an example. Let's take an regular expression A slash B star A B B. So this is a regular expression and we have to construct a DFA, the optimized DFA for this regular expression. So beta, you can see here A slash B star A B B. So we have to assume that star is connected with A by the concatenate symbol. In the same way, A is connected with the B with the concatenate symbol, and the another B is also connected with B with the concatenate symbol. So we have to assume the concatenate symbol within the regular expression. So let's create the syntax tree. So when we are creating the syntax tree, let's start from A slash B. So A and B are the operators, operands, and slash is the operator. Okay, now star is with A slash B. Then star is connected with A B B by the dot symbol or the concatenate symbol, right? Then A, and then A is also connected with B with the concatenate symbol. Then another B is connected with B, and for the hash also we have to take the concatenate symbol, right? So we have represented the regular expression in the syntax tree. Now the second is we have to number the leaf nodes. If A, then we have to number it as 1, for B 2, then another A 3, 4, 5 and 6, right? Then after numbering, we have to calculate the nullable by using these rules. So to calculate the nullable, if we are calculating the nullable of the leaf node. What was the leaf node? These are the leaf nodes. So while we are calculating the nullable, then we have to follow this. For nullable n, for any, if the node is the leaf node, then nullable is true. If leaf node with position I, then nullable is false. So here is not any epsilon to mark it nullable as true. So for A it is false, for B also it is false, C also it is false, false, false and false. Right. Then we have to compute, after completing the nullable function or after computing the nullable function, then we have to find the firstpos. And we before finding the firstpos, what we have to do? We have to also compute the nullable for the intermediate node. Then how we have to compute? If the node is slash, if the node is slash and it has C1 and C2, child C1 and C2, here we can see this is our intermediate node. If slash is our intermediate node, here is A, here is B, means this one is C1 and this one is C2. Then nullable is what? Nullable of C1 or nullable of C2. Either nullable of C1, either nullable of C2. So in OR condition F or F, the nullable is false, right? To compute the nullable of dot, or before computing the nullable of dot or concatenate symbol, we can compute the nullable of star. The nullable of star is always the true. So here it is true, and while we are calculating the nullable of concatenate symbol, we have to follow this rule: nullable of C1 and nullable of C2. Nullable of C1, for this concatenate symbol, the nullable the C1 is star and C2 is A. So here we can say C1 is true and C2 is false. You might remember, like if you are applying T and F, the logical gates, then it will give you the result of false, right? So nullable of dot symbol is false, and for this the nullable is false. For this also the nullable is false. For this also the nullable is false, because if the condition is true, true, then while we are using AND function, it is true, else it is false. For if the condition is FF, then also it is false. If the condition is true, false, then it is false. If condition is false, true, then it is false. So for all the concatenate symbol, the nullable is false for every intermediate node except the star node. Now, next is we have to complete the firstpos. We have already computed the nullable. Now we have to compute the firstpos. Then how we can compute? If the leaf node is epsilon, then the firstpos is phi. But here we can see there is no epsilon node. Then we have to compute with the next step. Label, if leaf label with position I, then position firstpos of n is I. Here we can see this A is numbered with 1. This A is numbered with 1. So, the first pose of A is always 1 by using this rule. Leaf label with position I, and the position of leaf node, that is A, is 1. That's why the first pose of that node is I. So, the another node is B, and it is also the leaf node with position 2. So, the first pose is 2. The first pose of this A is 3. The first pose of B is 4. First pose of this B is 5. First pose of hash symbol is 6. Right? By this, we can compute the first pose of every leaf node. Now, the rule to compute the first pose of the intermediate nodes. If the node is slash, then first pose of C1 union first pose of C2. For this, the A is for this symbol hash, A is C1 and B is C2. So, first pose of A, yani ki first pose of C1 is what? Union first pose of C2. First pose of C1 is 1, union first pose of C2 is 2. So, the first pose of slash symbol is 1, 2. Right? Now, we have to compute the first pose of, then we are going in upward direction. The next node is star. How we calculate the first pose for star? The rule is to calculate the first pose is, if the first for star symbol, if the node is C1, then the first pose of star is the first pose of C1. We can see here star C1 for star C1 is slash. So, the first pose and the first pose of slash is 1, 2. So, the first pose of star is 1, 2. As the rule says, if hash is the node, if star is the node, then for star, this one is C1 and the first pose of star is the first pose of C1. Now, moving further, next symbol is the concatenation symbol. So, to find the first pose of concatenate symbol, we have to use this rule. For concatenate symbol, if it has two symbols or two childs, C1 and C2, if nullable C1, then we have to check. This is our concatenate symbol. Yeah. For concatenate symbol, this one is C1 and this another A is C2. This one is C2. Then, if the rule is, if nullable of C1, C1 is what? C1 is star node. Is it true or false? If nullable is false, for this condition, if nullable of C1 is true, then we have to compute this function. Else, we have to if the nullable is false, then we have to compute the else function. From here, we can see this nullable of star means C1 is true. So, we have to use this rule. First pose of C1 union first pose of C2. So, for this concatenate symbol, C1 is star and C2 is A. So, the first pose of C1 union first pose of C2. First pos of C1 is what? 1, 2. Union first pos of C2 is 3. So, the first pos of concatenate symbol is 1, 2, 3. 1, 2, 3. Right. Now, we have to move in upward direction. The next symbol is again the concatenation symbol. Again, we have to use the same rule. If nullable of C1, but here you can see the nullable of C1. For this concatenate symbol, nullable is this concatenate symbol. So, the nullable of this concatenate symbol is false. Then we have to compute the else function. The else represent first pos of C1. So, the first pos of this concatenate symbol is the first pos of C1, and for this concatenate symbol, C1 is this concatenate symbol. So, the first pos is 1, 2, 3. Again, there is concatenate symbol. Then we have to find the first pos for this concatenate symbol, and we for this concatenate symbol, the below concatenate symbol is C1 and here B is C2. So, if nullable, then we have to compute the else. Else is what? First position of C1. So, for this function also 1, 2 and 3 is the first pos, right? And the next is also the concatenate symbol, and for this concatenate symbol, the previous concatenation symbol is the C1 and this one hash is the C2. So, if the condition is, if nullable is C1, if nullable of C1 is true, but here nullable of C1 is false. So, we have to compute the else pos function. That is the first pos of this is 1, 2 and 3. So, by this we have computed the nullable function as well as the first pos function of each node, whether it is the leaf node or the intermediate node. Now, we have to compute the last pos by using these rules. So, if the leaf node label epsilon, but there is no leaf node with epsilon in our tree, syntax tree. So, we have to ignore this rule and using the next rule, that is, if leaf node label with position I, then last pos is what? I itself. So, for this A, the last pos is its position and it is at the position 1. So, it is also the last pos. For this B, the last pos is 2 as it is the position of the node. For this, it is the 3. For this B, it is the 4. Last pos is 4. And for another B, last pos is 5. And for hash symbol, last pos is 6. So, for every leaf node, the last pos is same as its position. Like here, A is at first position. So, it is the first pos as well as the last pos for this position, for this node. In while we are going to B2 with position 2, the first pos is also 2 and the last pos is also 2. For this A, at position 3, the first position is first pos is also 3 and the last pos is also 3. For this node that is B at position 4, the first pos is 4 as well as the last pos is also 4. And next B with position 5, first pos is 5 and the last pos is 5. Now, the last leaf node is the hash symbol with position 6. So, first pos and last pos is always the 6. So, we have computed the first pos as well as the last pos for all the leaf nodes. Now, we have to compute the last pos for the intermediate nodes. So, to compute the last pos for hash function that has C1 and C2 as their child, the last pos is last pos of C1 union last pos of C2. So hash is our symbol. We have to compute the last pos for hash, and the rule says last pos of C1. If we have hash, it has A as C1 and B as C2, and the first pos of this A is 1, sorry, last pos of this A is 1 and the last pos of B is 2. So, to compute the last pos, it is the union of last pos of C1 and with the last pos of C2, that is last pos of C1, that is A, and union last pos of C2, or we can say B. So, last pos of C1 is 1, union last pos of C2 is 2. So, their union is the last pos for hash symbol. So, last pos for this symbol is one comma 2. Right, we have computed the first pos as well as the last pos for this hash symbol. Now we have to compute the first pos as well as the last pos. We have already computed the first pos. To compute the last pos for star symbol or the star node, the rule is for star node that has C1 as the child, the last pos is last pos of C1. So, this is the only child that C1 that star pos has. So, the star node has only one child, that is hash, and the last pos of C1, that is the hash for star node. So, this is also the last pos of star symbol. So, the first pos of star symbol is 1 comma 2, and in the same way the last pos of star symbol is 1 comma 2. So, now we have to compute the last pos for concatenate symbol by using this rule. If nullable C2, so for this condition, let's so, to compute the last pos for concatenate symbol, if nullable C2, for this symbol, this is C2. If this is true, but this is false as this is the leaf node. If this is true, then we have to compute this statement or this function, else we have to compute the last pos of C2. So, here you can see the nullable C2 is false. If it is true, then we have to compute the another function, but it is false, then the last pos of this, last pos of C2. So, the last pos of C2 is 3, which is the last pos of the concatenate symbol. Now, moving further, another we have the concatenate symbol. So, if nullable of C2 is here is B, if nullable is true, but here it is false. So, the last pos of this concatenate symbol is 4 itself. The last pos of C2 is the last pos for concatenate symbol. Now, the last pos of this concatenate symbol is also 5. Is also 5. Why? Because the C2 is false here. So, the last pos of concatenate symbol is the last pos of C2, that is 5. So, for this node is also it is 6. So, in this way we have computed the last pos and first pos for all the nodes, whether they are the intermediate nodes or they are the leaf nodes. So, this is the tree that would be look like this after computing the nullable, firstpos as well as the lastpos. So now next step is we have to compute the followpos. What the followpos is? If n is a concatenate node, if n is a concatenate node with left child C1 and right child C2, then for every position I in last pose of Ci, all position in first pose of C2 are in follow pose of I. What does it mean? If the symbol is concatenation, or we can say if the node is concatenation symbol, then we have to compute first pose of C2 to the last pose of C1, right? And if the another rule is, if the symbol, the follow pose is to be found for both the symbols, that is for concatenate symbol as well as for the star node, we will not find the first pose for the slash symbol. Okay, to find the first pose, to find the follow pose for star node, we have to compute first pose of n to the last pose of n. So let us first compute the star node, because this comes before the concatenation node. So we have to compute the first follow pose for this node. And what the rule says, time's up. Okay. So by using these rules, we can compute the follow pose for star node as well as for the concatenation node. After computing the follow pose, we get this table where n is the nodes, follow pose of each nodes, right? Then we have to compute the, then we have to construct the table or the DFA. Then we have to construct it if the node is, the table is like, we have two operators, two operands, and these are the states that we computed after solving the nodes as well as follow pose. And it represent A is the start node and C is the end node. A at A gives B and A at B gives A. B at A gives B, B at B gives C, C at A gives B and C at B gives A. So we have to always remember while you are designing or you are finding the DFA, then root node is always what? Root node is always the hashed symbol, that is this one. So this one is the root node and it has 1, 2, 3. So we assume A as 1, 2, 3 and we for A, that is 1, 2, 3, we assume it as state A and find A comma A, A comma B. Then we get another state from after computing these, that is B. Then we find B comma A, B comma B. We get another state C. Then we find C comma A, C comma B. After computing this, we get this type of symbol table. We can construct the symbol table as well as we can construct the DFA for this regular expression using this symbol table. So this is our DFA. Thank you so much.